Hi fellas, today I'm gonna derive the formula of Planck length and Planck time and Planck mass. So why not Planck temperature? Because my level, I haven't learned about Boltzmann constant, which is influenced by pressure, temperature, time, mass if I'm not wrong, and it's kind of complicated. It's in uni knowledge, so I haven't entered uni yet. I'm just a high school student, and what I know about is the three constant. The universal constant will be gravitational constant, which is influenced by Newton. Uh, Speed of light, Albert Einstein, and what else? H bar, which is Planck constant. H, which is Max Planck by me. Just joking. My name is Max, but I'm not Max Planck. Okay, so you might ask, what is Planck length, Planck mass, and Planck time? So when we talk about Planck, it is the quantum level that could ever exist in this universe of the smallest value. So you might let me give you an example. If I ask you, what is the smallest length that you can possibly think of? You might say, quark, or not. Let's say, for easy, virus. Virus is so small that you can't even use your naked eye to see it. You have to use the microscope, a very powerful microscope. So, is there anything else smaller than virus? Of course there is. But the thing is, what can we name it? We don't know. So what could be possibly the smallest length in this universe can possibly be? So how do we find it? I'm here to prove it to you. So other than Planck length, what is Planck mass then? Same concept, the smallest value that can all possibly be. So what is the smallest mass in this universe? It's so small, we don't know. How do we prove it? I'm gonna prove it to you. Same thing goes to Planck length, Planck time, the smallest duration that you can think of. Let's say 1 second. 1 second is not the smallest duration in time. You might say, oh, it's very fast, like 1 second, one. That's it. But what about picosecond? What about nanosecond? That's not even close to the smallest quantum level of time duration. So I'm gonna prove it to you. So how I'm gonna prove it? So first thing first, you have to know three constant, which is gravitational constant, speed of light constant, and Planck bar, H bar constant, which is Planck constant. So okay, here we're not gonna use value of, here to use the unit only. Okay, so G, gravitational constant, will be the unit of it, weight, meter cube per kg per square. This is negative. What about H? H bar. H bar will be meter square kg per second. Okay, and what? And C, speed of light, will be ms, meter per second. Okay, this is the three constant that we have to use. Why this constant? Why this constant have to deal with Planck length and Planck mass and Planck time? Because if you look into the formula of the units, it has meter, it have kg, it have second. So it does related to these three things. So why is it these three? You may ask, because these three constant is their universal constant in this universe. You can't escape from these three constants when you are learning physics. We are dealing with heat, we are dealing with thermodynamics, you are dealing with fluid dynamics, you are dealing with anything, gravity, general relativity. What about special general relativity? I don't know. You have to deal with these three constants every day in life. Or a quantum, I don't know. So, how I'm gonna do with it? What I'm gonna start with is that, let's say this three constant, I'm gonna power it up with different variables. So I'm gonna power with alpha, beta, and gamma. It's a Greek word, okay? Just a random unknown, okay? just to represent it. So if G are paired with alpha, which means 3 alpha, Kg negative alpha, second negative 2 alpha, and for H bar will be meter 2 beta, Kg beta, and second negative beta. Speed of light will be meter gamma, second negative gamma. Okay, so if you take a look, I'm gonna factor m will be 3 alpha. Wait, my handwriting is so bad. 3 alpha plus 2 beta, because I'm taking out the same mass, the unit of it, just the same unit. So this will be m. And what about Kg? Okay, Kg negative alpha plus beta, and there's no C for Kg. Okay, so S will be negative 2 alpha, negative beta, and negative alpha. So okay, these are the 3 equations. Mainly I'm gonna use it for the calculation, deriving for the Planck length. So Planck length, I'm supposed to know. So of course we are dealing with length. That means we need the important unit will be meter. So if it's the important unit meter, I'm gonna take the power equals to 1. And what about other else? They will be equals to 0 because I don't want them. They are useless. Kg and second, we don't need them. Length, SI unit will be meter. We don't need other unit. Kg is mass, second is time. They are not related to length, so I'm gonna put it others as 0. So same thing goes to second. Okay, so of course I'm gonna do the second equation because it's easier. So this beta equals to alpha. So I'm gonna bring it over to the first equation. So since beta is equals to alpha, so 3 alpha plus 2 alpha plus 1 gamma equals to 1. So 5 alpha plus gamma equals to 1. So gamma will be 1 minus what? 1 minus 5 alpha. So 2 negative 2 alpha minus alpha, because b equals to alpha. This is coming from here. And negative 1 minus 5 alpha equals to 0, because alpha is equals to 1 minus 5 alpha. I mean gamma is equals to 1 minus 5 alpha. I'm just gonna bring it over there. So if we are doing algebra, wait, negative 3 alpha, negative 1 plus 5 alpha equals to 0. If we were to find, this will be positive 1, negative 3 plus 5 will be 2 alpha, and alpha will be 1 over 2. Okay, keep in mind alpha is 1 over 2, and since alpha is 1 over 2, beta will be 1 over 2. So what about gamma? Gamma will be 1 minus 5, what the heck, sorry, 1 minus 5 alpha will be 1 over 2. Wait, I'm lagging. Okay, this is 1 over 2. So 1 minus 5 times 1 over 2 will be alpha negative 3 over 2. Okay, let me conclude. Alpha will be 1 over 2. Lagging. Beta will be 1 over 2 too. Gamma will be negative 3 over 2. So what is gamma, what is beta, and what is gamma? Just now I label. Alpha will be mass. Wait, is it? Wait. I mean, not mass, meter. This is in. Wait, let me check. Alpha will be G. This is G. Beta will be H bar. And C will be gamma. So what I'm trying to say is that G has to deal with negative 1, 2, over 2. Negative 1 over 2. This have to do with this, and this have to do with this. This is negative because alpha equals to beta, so they have to be negative. Is it? Oh, they are not negative, sorry. They are positive. I'm sorry. Okay. Since G and H bar has the same power, that means they have to be above of the denominator. Why? Because they have the same power, right? They have to be together. And negative 3 over 2, when you put when there's negative, of course it's denominator. GH is numerator, and it have a square root. That means it cancels out the 2, which is left with 3. So if you were to find the Planck length, this will be the smallest value in the entire universe. Let me check for you. So G will be 0.067 times 10 to the power of 11 times with H bar. Okay, H bar is actually 6.63 times 10 to the power of negative 34 divided by 2 pi, because you're finding the radian form, and divide by this constant. The smallest value that can achieve will be 1.61 10 to the power of negative 35 meter. This value, I have proven, this value is the smallest value that can achieve in this universe in quantum scale level. There is nothing else can achieve this value smaller than this. This is the maximum value you can achieve in this universe for the smallest value. Okay, so actually if you're doing the other parts, mainly for mass and for other mass and time, it will be the same. Just use my the calculation will be same. So you can try if you want to. So good luck. I hope you learn something. I hope you'll learn more about quantum scale level. So I will try to learn about Boltzmann constant. That's it for this video. Thanks.